Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. Hi, everybody. Hopefully you're ready for a fun afternoon. I sure am. All right, a couple of things I should mention. One, don't forget that you should learn the charts, and I'll go over that in a little while. But important thing, normally, even face-to-face or now, on Monday, we have all lecture, and on Wednesdays, normally, I'd go 50 minutes lecture, we take a break, then we do the lab. Well, because I'm going to lose in, I think a week from this Monday, not this Monday, but the following Monday, the whole day or afternoon, because the Labor Day holiday, I'm going to make it up. Now, when I say I'm going to lose it, not really, you're going to lose it, because if you haven't figured out, I know this stuff. But anyways, so today, instead of having a lab, and same thing next Wednesday, and if we were face-to-face, I would do the same thing in a classroom. We wouldn't have lab, we do lecture. So this way, I don't have to rush to make up this time, and it helps you learn the material better, which is a good thing. All right, now, remember, this is one of the most important things you should know, as well as you know your first name. Hopefully you all know your first name like that. And that is, there's 4 bonds to carbon. Yes, 4 bonds to carbon. 1, 2, 3, 4. Remember, if they're not 4, then the remainder are hydrogens. Now, on Monday, I started talking about nomenclature. Nomenclature is a fancy word meaning how to name things. And organic nomenclature is broken down by different functional groups. And we started out, and we'll continue today, with the alkanes. And we had learned, or you had learned, that for acyclic saturated hydrocarbons, they're the alkanes, and alkanes without branches are named according to the number of carbon atoms. And I'm going to assume everybody sees alkanes, Iupac names. Thumbs up, people. Give me a thumbs up if you see it. Thank you. You guys are good. And seriously, in Zoom, sometimes it'll tell me you can see it and you don't. And that's why I developed the thumbs up people. All right. Now, this is the alkane name. Now, it goes a lot more than just 10, but for this class, 1 through 10 is sufficient. And we'll be all right and work for you and me too. Now, you should know methane, 1 carbon, butane, 4 carbons, octane, 8, decane, 10. You should know this chart as well as you know your first name. If you don't, you're going to lose 50 points out of 100 on test number 1. Test number 2 and 3, about 34 points, not as many as test 4. And the final, you lose about 35, 40% of the total points. So it helps. And let me be subtle. Know this chart. What I mean by that is you should know methane, 1 carbon, propane, 3 carbons, and so on. Now, I taught you on Monday, I think the best way, much better than flashcards, and I've seen this with my students over the years, is you take the time, and when you're alone, or you can be within a crowd, but it works better probably when you're alone, you write down methane 1. and you say it, or 1 carbon. Then you do it again, methane, write it down, put down 1 carbon, and you say it, methane, 1 carbon. Do that 5 times, do that on 2 different days, and you'll burn it into your brain. How that works, well, I don't know. I'm a chemist, not a psychologist or psychologist, but I know it works. By next week, you should know this chart. You're not going to learn organic chemistry and memorize this a day or 2 before test 1. You won't like the results, either will I. So make Dr. White happy, learn this chart. Thank you. All right, so if I were to say, draw the structure of pentane, what do? Well, you learn the chart I just showed you, and pentane has 5 carbons. So I'll put them in, and they're all in a straight chain. And now I'm going to let you put in the hydrogens, because that's something else you have to do. And sometimes I'll write, draw the structure for, or draw the structure with all necessary hydrogens. Remember, there's 4 bonds to carbon. One thing, if you'd like me to call you a different name, if I remember talking to you based on not the name that the school uses, but you have another name, email me and let me know, and I'll make sure I do that. When we're face to face, I've had one case, someone called Susan said, no, call me Molly. I like that better. And for Katerina, I've had, I don't know how many variations, Cat, and so on. And anyways, one was Kasha for Katerina. But let's go through this. Remember, 4 bonds to carbon. This one has 1, 4 minus 1, 3 hydrogens. This carbon has 2 bonds, should have 4, 4 minus 2, 2. Same thing here, same thing here. And finally, this has 1 bond, should have 4, 4 minus 1, 3. And that's the structure for pentane. Now, I started talking yesterday about what happens when you have a branch. In other words, you don't have a straight chain. Aren't you glad I have this tablet? It makes life so much easier for both of us. It's like me in a classroom with a whiteboard. All right, what is the Iupac name for? And here I give you a structure of a molecule. Now, remember, Iupac means the official name. I'll never ask on a test, but I just think it's cool to say International Union of Pure Applied Chemistry. and that's the official organization that governs and the rules for all organic molecule or all molecules, but the majority, like 90% of their rules, are for organic molecules. That's because organic chemistry rocks. It's the best, but I'm biased. So what do? You have to find the longest chain. And the longest chain are what's the most carbons bonded together directly. Think of it as like links on a chain. Well, the only way I know how to do it is start counting. If I count across 1, 2, 3, 4, 5, 6, 7, 8. That's one chain. Let's look at another chain. Let me get my, hold on one sec. One, two, three, four. Now this carbon 4 is bonded to this carbon, so I'll call it 5 and 6. That's a chain. And there's one more chain. I can start here, 1, 2, 3, 4, 5, 6, 7. Now, as I said, this part of the semester, you have to know between how to count up to 10 and what numbers are greater than other numbers. And if you look, we have 3 choices, 6, 7, or 8. And what's the largest number? And we all picked 8. So the longest chain is 8 carbons. Now let me clean up a little here. If we were in a classroom, you'd see me with an eraser in my hand. So what do we do next? Well, the longest chain is 8 carbons. And we look at them. You have memorized this table. And 8 carbons, octane. So that's the root name. The longest chain is called the root name. So we put that down, octane. Oops, I want to do red. Now, are we done? And the answer is no. Why? Because as soon as you say octane, these 8 carbons are spoken for. But look, we have something left over, CH3CH2. And that's called an alkyl group. And alkyl groups have names. By the way, let me back up for 1 second. This table, alkane Iupac names, are in the lecture folder of D2L, secretly named alkanes Iupac names the number of carbon atoms. So you can download it or look at it online any time you want. I have it both as a Word and as a PDF file. Now, the other important file you should start learning are the alkyl groups. This is also in the lecture folder of D2L and is secretly named key alkyl groups. And 2 carbons, CH3, CH2, bond to something. That's what this line is. It's called the ethyl group. Now, time for Dr. White to be subtle again. You should know this chart as well as you know your first name or anything else you know like that. I don't know how to count up to 10 or whatever. And how do you do that? Put CH3 line methyl. Write it again and say it. CH3 methyl, CH3 methyl. Then ethyl, 2 carbons, CH3, CH2, with a line to the end carbon, meaning whatever the longer chain, or later on we'll learn rings, is to the N carbon. That's called an ethyl group. And 3 carbons has 2 choices. To the N carbon of 3 is N-Propyl. To the middle carbon of 3 is isopropyl. And finally, the 2 alkyl groups with 4 carbons. When you have 4 carbons, CH3, CH2, 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 and bonded the end one to something else, that's called N-butyl. When you have 4 carbons, 3 CH3 groups bond to center carbon, that center carbon is bonded to the chain or a ring. We call that a tert-butyl. But next week sometime, I'm going to be a lazy organic chemist, and we are, and I'll just call it T-butyl. You can call it either way right now or whatever, but I'll call it T-butyl. By the way, Dr. White loves isopropyl and T-butyl groups. They've been good to me. I've been good to them. And I also like methyl and ethyl and the others that I didn't talk about. I really like isopropyl and T-butyl. All right, let's go back to our example. We have an alkyl group, CH3, CH2, and that's called ethyl. So we have this right here, and that's ethyl octane. Now, one of the bad habits I do, I sometimes mix cap letters and lowercase when I'm handwriting it. If you were to keyboard it, even though I won't take off points ever on a test, if you mix it like I do, but the Iupac rules are, those are all lowercase. And between letters, there's no space. But if your space is, you got a space there, as long as the answer isn't on the next page part of each one, I don't sit there with a ruler. Oh, it's more than 5 millimeters apart, I'm taking off. No, I don't grade that way. Now, are we done? No, because if I were to send a letter, postcard, or whatever to you, I put your name, your street name, your city, and your state, and your zip code, would you get it? Probably not, because what did I forget? Your apartment number, or condo number, or house or home number. And the same thing is true with alkyl groups. You have to put a number in front of the name of the alkyl group stating which carbon that alkyl group is on in the octane root name. How do we do that? You always start numbering from the end, and you go from both sides. I start here, 1, 2, 3, 4, 5. And if I make a mistake counting, someone correct me immediately, please. Now, we have 2 possibilities. If I start in red, it's on carbon 4. If I start in blue, it's on carbon 5. Iupac rules are, you start from the end that has the lowest, gives the lowest number to all the alkyl groups. We're dealing with this one, but you can have more than one. And hopefully all agree 4 is less than 5. So this is 4-ethyl octane. And that's how you do it. All right. In number B, or part B, whatever you want to call it, I'm going to do what's called fading prompts. Also, I call it Winky Dink. Anybody know the Winky Dink show? Nope, you don't, because that was on when I was about 5. But anyways, I'll explain that later. First of all, that molecule, I'm going to ask you all, find the longest chain. Your turn. That's all I'm going to ask first of all. And by the way, thank you for all coming today. And those who have your web camera on, thank you. All right. Give me a thumbs up if you're done, if you found what's the longest chain. Use either your video, you can just hold your, or use your emoji. I tell you, I'm starting a campaign to change the word emoji to symboli. It's really a symbol. Never mind. All right, it's Awful Humor Wednesday. That was pretty awful. All right, let's do it. What's the longest chain? Well, I've got to start counting. I count across 1, 2, 3, 4, 5, 6, 7. That's one chain. I can start here, 1, 2, 3, 4. Remember, this carbon is bonded to this carbon. They're linked together. That's a chain. In this molecule, there's one more chain. 1, 2, 3, 4, 5, 6. So you have 3 choices, 4, 6, and 7. Hopefully all pick 7 is the longest chain. Now, what's the name of alkane with 7 carbons? Well, hopefully you'll take my advice, and this week, rest of the week and weekend, you'll start memorizing this table. And 7 carbons is heptane. So the root name is the longest chain, heptane. Now, as soon as we say heptane, those carbons are spoken for. Are we done? No. We have 1 carbon, CH3, an alkyl group. That's what a branch is called when it's only carbon, hydrogen, some carbon, single bond, which is we call that an alkyl group. And how do we find that name? Well, you look at this table. If we were in class, I'd have these both on the board, but it's harder on Zoom. CH3 is called a methyl group. Again, CH3 is a methyl group. And I hope you all spend the rest of this week or this weekend learning this, memorizing this table. Yes, there's a lot of memorization in this course, but I'll give you the tools how to do that. So we now have the alkyl group CH3 is called a methyl. Now, I'm going to let you try what carbon is the methyl group on. Remember, you number from either side, and the number that's the lowest is the correct number. And when you're done, give me a thumbs up, either with your webcam, hold up your thumb, or do the emoji. I guess unless you're driving your car listening to me, and you can't do that. I actually at another school, I had someone doing that because it was an internet class. All right, I think everybody's done. Let's take a look at this. If we start from this side, it's on carbon 3. We start from this side, 1, 2, 3, 4, 5. It's on carbon 5. Iupac rules are you number from the ends to give the alkyl groups the lowest number. So the lowest number is 3, and it's 3-methyl heptane. That would be the Iupac name. Now, between a number and a letter, you put a hyphen. If you forget that, I will never take off points, but I might write it. Well, if we were on face to face when I handed it back. All right, now listen carefully. A common mistake students make on test one, I'm telling you this so you don't, is they call this carbon right here 1. When the first alkyl group they encounter, they say, oh, I'm going to make that carbon 1. Wrong. You can only make the ends of a chain either end 1 when you're starting your numbering. All right, first of all, I'm going to let you figure out what's the longest chain. And when you get the longest chain, give me a thumbs up. I see a couple thumbs coming up. I see some more. All right, looks like everybody's done. The longest chain is 4 carbons. Now, you have not had time to memorize the alkane names, so I'm going to help you out. What's 4 carbons? Everybody see the table? It's butane. 4 carbons, butane. Are we done? No. As soon as I say butane, this is all spoken for. And what do we have here? Oh, a CH3 group. Hint, hint. What do you think that's called? Look above. Hint, hint. It's a methyl group. Now, I'm going to let you figure out what carbon is the methyl group on. And when you're done, give me a thumbs up. If we were in a classroom, I'd say look up and smile, but not all of you have your webcams turned on, so I can't see you smiling if you did that. All right, I think everybody's done. Let's take a look at this. You number from the end, 1, 2, 3, 4. And there's one other way to number it. 1, 2, 3, and 4. Now, the methyl group is on this carbon, and there are 2 possible numbers, 2 or 3. And Iupac rules are you take the smaller number. Hopefully you all agree that's 2. So this would be 2-methylbutane. And that's how you do it. Now, let's talk about what happens when you have more than one alkyl group.
Actually, I have a question on C real quick.
You can make it real slow too.
For that one, there's 2 chains.
Stop. Let me get back to, all right, here we are. Go ahead.
Okay, so there's 2 different chains of length 4. Does it matter which one I choose as my longest chain?
First of all, excellent question. Thank you for asking that. Let me write it down. Now, one of the beauties, and in my mind, it is beautiful and awesome what Iupac accomplished over the years. Any structure only has one Iupac name, and any name is only for one structure. So let's rewrite this. Okay. Now, what if I called the chain 1, 2, 3, 4, which is, I think, Joe, that's what you're asking, correct?
Yep, that's the other chain I'm looking at.
Right. Well, let's take a look at this chain. Here's the chain, right? How many carbons? 4. What do we call 4 carbons? Butane. What's left after I circle all the carbons in butane? Oh, look, a CH3 group. What do we call that? Methyl. One of the problems when I do this on a whiteboard too, I do it on paper when I'm alone, is, always give yourself enough room. And now we have to figure out what carbon is it on. The way I have it numbered is on carbon 2. If I started the other way, 1, 2, 3, which is the lower number? Hopefully you pick 2. And that's one of the things about molecules with carbon atoms. You can bend them. They rotate. I'll show you later on. Where's my model? Hold on. Time out for getting my model. And this is something initially it's time for Dr. White's show and tell. Now, think of this as 1, 2, 3, 4 carbons, even though I draw it straight across. And notice here, carbon with 3 hydrogens, every end of the tube is a hydrogen. This would be this compound looking the first way I drew it. But if I drew it this way, all I'm really doing is rotating it like this. See how I can rotate things around? One way it was this way. Yeah. And then if you look here, this is that second chain. And here's my, stay in place, my methyl group. And so does that help you understand that even though there are 2 possibilities, when you look at the name, if you get the same name, if you do it correctly, which I did, you have the same molecule. There are different orientations how you can draw a molecule. Here's an example. What do I have in front? My right hand. If I were to say, close your eyes, I went like this, and you open it, I said, oh, look, it's something different. And you go, come on, give me a break. You just rotated your hand 90 degrees. And molecules, students tend to forget this. And I can understand why, but they really rotate all the time in 3 dimensions, just like we do. But when we write them on a piece of paper, you think of them as being glued down in one way. Does that help?
Yeah, that makes sense. Thank you.
Good. By the way, all questions are good questions, and thank you for asking that question. All right, now, what happens when there's more than one alkyl group? Each substituent, which for ours we're using alkyl groups, is located by its name and by its number on the carbon atom to which it's attached. When there are 2 or more, I have identical groups to use the prefix di, tri, and tetra. I'll come back to this in a little while. Every substituent must be named and numbered. If 2 or more, and here where I'm going to do next before I do the same, different types of substituents, meaning alkyl groups, because alkyl groups is a subset or a type of substituent, are present, they are listed alphabetically, except the prefixes like di, tri, or N or iso are not considered when alphabetizing. What does that mean? Well, let me show you how to do this. But before I do that, let me tell you, initial nomenclature I'm going through is about as exciting as going into a 5-star restaurant. If you don't know what that means, Michelin 5-star restaurant is usually one of the best restaurants in the world, and sitting down and ordering, give me 2 or 3 pieces of plain white toast. In a fancy restaurant like that, but it will keep you alive. And this is an important part about nomenclature. It's an important aspect of organic chemistry. Ooh, using that analogy, plus will help you get a good grade. Does that make it relevant to you now? But let's look at the example here. Again, question is, what's the Iupac name? Uh-oh, I almost forgot. First, I'll let you all write this down. Now I'll help you out. There are 9 carbons across. On this carbon, there's CH2, CH3. On this carbon, there's CH3. Tonight at midnight, I'll be giving speed structure drawing lessons. No, I won't. All right. But before I move on to this, everybody got it written down? I'll come back to it. Starting next Monday, it will be your solemn responsibility in my class that when I write a structure like I just did, you're to check to make sure all bond carbons have 4 bonds to it. Once in a while, since I'm writing hydrogens and numbers at warp drive, for those who don't know science fiction, that means as fast as I can, beyond the speed of light, I will make a mistake one time where I should put a 2, I might put a 3, or where I should put a 2, I might just leave it with 1 hydrogen. If I make that mistake, starting Monday, it is your solemn responsibility as a student in my class to let me know I made a mistake. Remember, there are 4 bonds carbon. Uh-oh, this is broken. 4 bonds carbon. All right, for this one, I'm going to show you the longest chain, and that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. If you go to table for alkane names, hint, you should learn this as soon as possible. 9 carbons, no name. So the root name is no name. As soon as I say that, this is all spoken for. Now notice we have 2 alkyl groups, one with 1 carbon, CH3, and one with 2 carbons, CH3, CH2. And if we go to the alkyl group table, which, oh, someone said, hint, know this. Again, this is something else. 1 carbon is methyl, 2 carbons ethyl. 1 carbon methyl, 2 carbons ethyl. So this is a methyl group. Now on a test, you don't have to do all the circling and everything like this, but I'm trying to teach you, and this helps you visualize what I'm talking about. This is an ethyl. Now the Iupac rule says E comes before M, so this is ethyl and methyl, no name. Now, what carbons are they on? Well, you again have to count from both sides. Now, if I go by the black numbers, the ethyl group is on carbon 3, and the methyl group is on carbon 4. Now, if I go with the red numbers, my ethyl group is on 7, and methyl is 6. Iupac rules are you assign numbers and count from the end of the chain such a way that the alkyl groups get the lowest numbers. Which is lower, 3 and 4 or 6 and 7? And time's up. Hopefully all picked 3 and 4. And therefore, I can now say the ethyl group is on carbon 3, and the methyl group, let me make a little room for myself. Oh, I didn't want to do that here. The ethyl group is on carbon 3, and the methyl group is on carbon 4. So that's 3-ethyl 4-methyl nonane. Say that 5 times quickly. No, you don't have to. And that's how you do it. Now, it's time for a little gift from Dr. White. Little gift, but still a gift. Now, when it comes to alphabetical order, the name that's alkyl group that's closest to the front of the alphabet comes first in the name, not the number, but the order. Notice I had ethyl in front of methyl. Excuse me. Now, when you have something like isopropyl or N-Propyl versus, say, methyl, you forget about the prefix N or isopropyl, iso. And so N-Propyl, isopropyl is really a P. And that can get very confusing for people like you who are just starting out. So therefore, on my test and my final, I will not hold you to the alphabetical order rule of Iupac. Don't tell the Iupac, please, I'm doing this. There's no Iupac, please. But I'll make your life just a little easier. So I will always follow the Iupac rules. So the correct Iupac name is 3-ethyl 4-methyl nonane. And also in my answer keys, I'll do that. But if you had put down in a test 4-methyl, then 3-ethyl nonane, I give you full credit. And that's my gift to you. And let's have you try one. Now, these examples I make up on the fly, so I'm going to teach you about the 20-second rule, or even 15 seconds. Give me about 10, 15 seconds before you start writing this down, before you start, because I might change my mind, because I'll write an example that really doesn't show what I'm trying to illustrate. In this case, that's not the case. Now, I will tell you this to help you out today. This is called an isopropyl group. Oh, it's your soon-to-be old friend, the methyl group. And I'll let you figure out how many carbons are in the longest chain. Does everybody have it written down? Okay, so what I'm going to do is help you out. Once you find the longest chain, here's the Iupac chart on what that would be called. When you're done with everything, give me a thumbs up. I'll give you a big hint. 10, decane. And when you're done with this name, let me know and I'll do it. Give me a thumbs up when you're done. Thank you, Megan. Am I pronouncing your name correctly? Thank you. And the next person already had someone with your first name. So Yesenia, is that the correct way to pronounce it?
Yeah, it's the correct pronunciation.
Like I said, I had someone else long ago teach me when I didn't know how to say it correctly. All right, anybody need more time? Okay, let's do this. Now, I helped you out. The longest chain is this, and it's 10 carbons, decane. We have left over a methyl and isopropyl. Now, which carbons are they on? I start from this end. Remember, you can only start for alkanes from the N carbons, not in the middle somewhere. It's a common mistake students make. And I have two choices. It's either on carbon 3 and 4 or 7 and 8. Which is the smallest number? Hopefully all pick 3 and 4. The methyl group is on carbon 3, so it's 3 methyl. And the isopropyl group, 3 carbons to the center carbon, is on carbon 4. So it'd be 3 methyl, 4 isopropyl decane. Now, if you had written down 4 isopropyl, 3 methyl, I would not take decane, I would not take points off, even though this is the correct Iupac way, following all the rules, including alphabetical rules. And that's how you do it. Now, at this point, you're sort of saying, whoa, this looks confusing. With practice in a couple of weeks, you'll say, how did I ever find this hard? Well, you found it hard because you didn't know it. Now, one of the things I do want to point out, and give me a second while I open it up. In D2L, you'll see a lecture folder. You'll see a folder for practice problems and a third folder for practice problem answers. Now, once we finish the chapter, I'll say next, whatever class, we'll go over this. And I'll ask you to do these before that. Now, notice what I've done. For problem 1, I've asked how many carbons are in the longest chain. And being the nice person I am, I didn't even put down hydrogens so they wouldn't confuse you. And you should do these. Next, I asked, give the Iupac names, which we've been doing. And notice 3 carbons. Oh, I know what that is. Remember, how many of you remember propane? I didn't do it enough times on Monday. But anyways, that's propane. Someone has a question.
Oh, no, I was raising my hand to say that I remembered propane.
Oh, okay. Usually people do thumbs up, but that's fine. Now I'll know if you raise your hand, you're doing that too. Okay? And we'll be doing more of these, but these are things you should practice just like I'm doing here. Oh my goodness, I went a whole minute over our break time. I'm not going to cheat you out of a break. Let's take a break. And by my clock, come back at 5 minutes at 1:56. And I'll see you in 5 minutes. I'm going to get up and stretch. Time to start. Welcome back. All right. Now, again, let me remind you, nomenclature is not that exciting. However, it's an important part of organic chemistry. I don't know, how many of you remember back? I can still remember it. I have a photographic memory for a lot of things. Sometimes that's good. Sometimes, oh, it's not good, but most times it's good. I can still remember back in first grade, we had the little reader book, and they gave us a piece of plastic so you could follow each sentence. Remember when you were first learning how to read? And did you have C Jane run, C Dick run, C Spot run? Why do I still remember that? And that's when you started learning about how to read words. And then you started learning how to read and read books. And my parents loved to read. They instilled that in myself and my sisters. I have two sisters. And to this day, I love to read. And there are a lot of great stuff out there. How many of you read the Harry Potter books? One of the English instructors who I know at ECC years ago, when the second one came out, kept on bugging me. Have you read this great books? What? Harry Potter, but what's it about? What's the kid's story? I'm not a kid. We got to read it. And finally, to get her off my back, I read it and I got hooked big time. But anyways, nomenclature is the same way. Let's go back and I need to show you another case. And let's look at the following molecule. Thumbs up, people. Can you see my white screen? Thank you. And a question would be, what's the Iupac name for this? Well, I'm going to do it. The longest chain, any way you can do it, is 3. That's propane. Again, I can't stress enough, so I'm going to stress it again. You should learn, hint, this table as soon as possible. Best way to learn it is writing it down, each one 5 times and saying it. Propane, 3 carbons, propane, 3 carbons. Now, as soon as I say propane, these 3 carbons are spoken for. Oh, look, we have this left over, an alkyl group, this one, and they're both the same. They're your soon-to-be good buddy, your good friend, a methyl group. Well, how do we do that? Well, normally, if there was 1, I'd put methyl there. But now we have 2, and we have prefixes in organic chemistry. And di is for 2 groups. Tri, like in trident, 3 groups. Now, I've never used that other than a very bad joke that I won't inflict you with that. Tetra is 4 groups. But in reality, you need to know di, and I don't have it on the chart, but that's why I'm writing. Di is for 2 groups, tri is 3. So how many methyl groups do we have? 1, 2. So now we have dimethyl. And I got a space too far apart. And these are all lowercase, even though I do mix it up. Now, for each alkyl group, you need a number. So as soon as I see dimethyl, di means 2, I need 2 numbers. So what carbon are the methyl groups on? Well, in this case, they're on the same carbon. Now, if you just put this, I'm going to mark it wrong, because di means you should have 2 numbers. You only see 1 number. And where's the other methyl group? You can't assume it's on the same carbon. You never have to guess what an Iupac name. And the correct way would be 2,2 dimethylpropane. So whenever you have two di group, you need two numbers. If you have tri, three numbers. All right, I'm going to help you out. Well, no, I'm not. Why don't you find out what's the longest chain, then I'll tell you what it is. Okay, let's take a look at this. The longest chain, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So longest chain. Uh-oh, I'm seeing spots between on my screen. Longest chain is 5. And normally, not always, hint, you'll see these written straight across. So I'm going to do 1, 2, 3, 4, 5. And since you haven't memorized it, I'll give you a second to look at what's the name for the root name, 5 carbons. See why it's important to learn this table? Because you won't have it when you take the test. And 5 is pentane. So the root name is pentane. And once you say pentane, this is spoken for. Now, I'll let you try and fill out the rest of it. Ready, set, go. And look above. When you're done, give me a thumbs up. And thanks to all the thumbs up people out there in Zoom land. I don't say that again, but I do say thank you. All right, let's do it. Looks like everybody's done. So once I circle the 5 carbons, what do I have left? Oh, look, 1, no, 2 of your soon to be very close friend, the methyl group. I have a methyl group. There are 2 of them. Therefore, I use the prefix dimethyl. Now, as soon as I see di, that means I need 2 numbers in front. You number from only the ends. In one way, I've numbered already. Let's do it the other way. Notice one way, the methyl groups are on 2 and 3. The other way, the methyl groups are on 3 and 4. You always pick the way that gives the overall groups the lower number, which means you have di, you need 2 numbers. It's on carbon 2, 3. That's 2,3-dimethylpentane. And that's how you do alkyl groups. And with the other ones, you do it the same way, except the name is different. Now, when it comes to organic chemistry, there are 2 skills you should have in organic chemistry, which also really means there are 2 types of questions I can ask on a test for nomenclature. Nomenclature is the fancy word meaning how to name things. One is, here's the structure, give the Iupac name. The other is, here's the name, draw the structure. And let's see how to decode that secret name so we can find out what to draw. Sometimes I'll write give or draw. And sometimes I'll also write draw the structure with all necessary hydrogens for, and the first one is propane. Well, what do? Well, that's just a simple alkane. And you have learned, hint, hint, this chart, propane, 3 carbons. So the first thing we do is I'm going to write down my 3 carbons. And I put lines so my structures are straight. You don't have to. And now I know there's 4 bonds to carbon, and I can put in the hydrogens, 4 minus 1, 3, 2 bonds to the center carbon, 4 minus 2, 2, 1 bond to the end carbon, 4 minus 1 is 3 hydrogens. There's propane. And why don't you try one? Draw the structure for butane. And to help you out today, you can't do this on a test, but here's a table that will help you out. And hopefully you all figured out butane has 4 carbons in a straight chain. And when you're done, give me a thumbs up. Doesn't it feel good? You can do organic chemistry and it's not that painful. All right. I think everybody's done. Let's do this. I have butane, 4 carbons, 1, 2, 3, 4. Remember, this part of the semester, you have to know how to count up to 10. And also add and subtract up to 4. This carbon has 1 bond, 4 minus 1, 3 hydrogens. This carbon has 2 bonds, 4 minus 2, 2 hydrogens. This carbon has 2 bonds, but should have 4, 4 minus 2, 2 hydrogens. This N carbon has 1 bond, 4 minus 1, 3 hydrogens. And that's the structure of butane. And that's the liquid in the lighters. Either you're still smoking for cigarette lighters or for your barbecue or your fireplace. I have a admission to make. A long time ago, for many years, like almost 15, I was a chain smoker. And I mean, it was really bad. It was so bad back then you could smoke on planes, and I would know how many cigarettes I needed in my shirt pocket to go from O'Hare Airport to various airports, not only in the United States, but in the world. Detroit was a 2-cigarette flight. Newark, which was easier to fly into to get to New York City back then than LaGuardia, was about 8 cigarettes. Amsterdam and Manchester was about a pack and a half. Luckily, I gave it up in 1985. If you smoke, give it up. You'll be grateful you did. But anyways, let's get back to how do you draw the structure from a name? And let me show you how to do this one. Now we have 3-methyl octane. What do? for all organic names, when you're trying to decode it to find out what's the structure, you always start from the right and move left. You always start from the right and move left. The first thing I see is octane. And I have learned the table of the alkane names. Octane, 8 carbons. So immediately I put down 8 carbons. Now I go next and I see methyl. And oh, it's your old soon-to-be good friend, the methyl group. But in case you forgot, you should learn this table. Methyl means CH3 attached to something. So I have a CH3 group. And where is it? It's on carbon number 3. Well, I call this 1, this 2, this 3, and I put a methyl group, 1 carbon. And now I put in hydrogens, so I know there are 4 bonds to carbon. And that's that. But wait, there's something I want to show you. And I think it also pertains to the question, good question, Joe asked. And that is, if I have my 8 carbons, what if I start at this end? 1, 2, 3. And carbon 3, I have my methyl group, 1 carbon. So I'll put it here. And now I'll put in my hydrogens. And for discussion, let's call this X and let's call this Y. And the question it would be, which is the right answer, X or Y? And the answer is both. Wait a second, how can that be true? Well, it's hard for you to see, so let me give an example. Is this my right hand or is this my right hand? This one or this one? And the answer is that both. All I've done is rotated 180 degrees. And molecules like my hand can rotate all the way around. And if we look at the answer I just had, notice if I rotate X 180 degrees, I can see it, but you might have trouble. You'll get Y. If I have Y and rotated 180 degrees along an axis going up and down, you'll get X. Now, the question is, which one can you put on a test? And again, I'll say both of them. Good news, I have a piece of paper signed by the Board of Regents or President of Board of Regents of Michigan State University and the President of Michigan State University that I understand and know this, my PhD degree. And you can do it either way. And why don't you draw the structure for 2-methyl butane? Now I'll help you out. Here's the table. How many carbons in butane? You look at the table, 4. And I think by now, I think all of you figured out what a methyl group is, but I'll help you out again too. If you look at the other table, you should know, and wrong thing. Right thing, CH3. And when you're done, oh, I got you guys trained already. Thank you for helping me out. When you're done, give me a thumbs up. And for those of you who are done earlier, please be patient. I try and give everybody time to finish. All right, time for me to get to work. How do we decode this? Start from the right, move left. Butane, 4 carbons. I'll draw them out. By the way, I've found in life, or better yet, in organic chemistry, leave the hydrogens for last. It makes your life easier. All right, butane, 4 carbons. I have a methyl group, CH3. It's on carbon 2. 1, 2, methyl group. You could have also started the other way. 1, 2, methyl group. And I know there are 4 bonds to carbon, so I can put in my hydrogens. Now, let's look at carbon 2. Why is there only 1 hydrogen? Well, it's got 1, 2, 3 bonds to it. 4 minus 3 is 1. And that's how you do it. Any questions? Remember, in my class, there's no such thing as a dumb question. All right, let's see if you guys are up to the challenge. Uh-oh, what is he going to do? And the question would be, draw the structure 2,4-dimethyl octane. Now, in case you haven't learned it, octane is 8 carbons. Di means 2, tri means 3. Don't forget to put in the hydrogens. And when you're done, I see one person already is. Give me a thumbs up. Oh, a couple more. Oh, a lot more. But I'll wait. One of these days, I'm going to bring a tape of game show music while you're doing this. You know how they play that music when the contestants are thinking about an answer, like, I don't know, I haven't watched game show programs in decades. They were never high on my list of things to watch. All right, let's get to work. How do you decode this to know what to draw? You start from the right, move left. Octane. Hopefully you will be learning that chart starting this weekend. Octane, 8 carbons. Next, methyl. Oh, I know that's CH3, but it's dimethyl, and that means there are 2 of them. So where are they? On carbons 2 and 4. So if I start counting from this end, that would be 1 structure. Most of you are probably going to do that, but you could go from the other. And now I know there are 4 bonds to carbon. and I'll put in my hydrogens. Remember, starting Monday, it's your responsibility. If I make a mistake on how many hydrogens in a molecule, let me know. All right, so octane, 8 carbons. On carbon 2 is a methyl, carbon 4, because dimethyl means 2 methyl groups. And that's how you do nomenclature of alkanes. Now, I will be honest with you. Sometimes you have a structure where there's a gray area. How do I do this? It can get very challenging. Good news, on my test, I stay away from gray areas. It's not fair to you people to do that. So you just go, oh, he's being nice. All right, let's get, first of all, any questions so far? Going once, going twice, let's move on. Now, I've talked about alkyl groups. I'm going to hold off on the halogens as substituent, meaning fluorine, chlorine, bromine, or iodine, till we get into chapter 4, aromatic compounds. And you'll see it's a good thing. I've already covered this, name of the alkyl groups, methyl, ethyl. I'll talk about later on, not now, fluoro, chloro, bromo, and iodo for a fluorine atom, chlorine atom, bromine atom, or iodine as a substituent instead of a methyl group, say. Again, know the alkyl groups. Let's talk about cycloalkanes. Cycloalkanes are drawn this way. And each bend in a carbon, each bend in a line is a carbon. So if we look at this following structure, it's a ring, a cycloalkane. Remember, cyclo means round or ring. And how many carbons are there? 1, 2, 3, 4, 5, 6. Now, the way you do cycloalkanes, and again, I'll never ask you what are the rules, but you should know how to use them. And the ring portion serves as the base name, but the prefix cyclo is used to indicate the presence of a ring. So you look at the table for alkanes, you determine how many carbons, use that name, and then you add the prefix cyclo. So let's see how that's done. Well, I've got 6 carbons. If that was an alkane, not a ring, what would we call that? 6 carbons, hexane. 6 carbons, hexane. Again, I highly recommend this week and weekend you start learning this chart. So 6 carbons is hexane, but this is a ring, and a ring you show by the prefix cyclo. So the name of this molecule is cyclohexane. Again, count the number of carbons in the ring. Each bend is a carbon in the line. Find that number and name in the chart I just showed you, and then add the prefix cyclo. Common mistake on test 1, and I'll remind you later again, students, for if I ask, give the Iupac name for this structure. and they'll put down hexane. And when I give them 0 points, they start arguing, well, can I get partial credit? I said, no. If I don't know how many of you have taken anatomy and physiology. I haven't. I've had enough students to. If I ask you, give the name of this, and you put down foot, and you say, shouldn't I get partial credit? They both have 5 digits. No, it's a hand, not a foot. Well, in my mind, hexane and cyclohexane are just as different as hand and foot. And that's how I'll grade it too. Did I tell you I'm this close to the person who grades the test and final exam this class? Me. All right, let's try one for you. Uh-oh, that looks ugly. Let's do a better ring. That's better. First question I'd asked you to figure out how many carbons in that ring. I'll give you another 6.2 seconds. Go. 6, 6.1, 6.15. Time's up, and the answer is 5 carbons. Every bend in a line is a carbon. And what do we call 5 carbons? Let's go to table of the Iupac names. 5 carbons is pentane. But this is a ring, so the root name is the prefix cyclo along with pentane. And therefore, the full name, the correct name for this ring is cyclopentane. Oh, sorry about that. 3 carbons is propane. I just gave it away. What would be the name of this ring? No, it's not a triangle. It's a ring in organic chemistry. And when you're done, give me a thumbs up. How many of you have ever seen our gang, like on YouTube? When I was a kid, it was on TV. It's a serial about these kids, young kids from the 1930s when it was originally made. And they had the high sign. Amazing memories from your childhood. All right, what's the name of this? 1, 2, 3 carbons, propane. And it's a ring, so it's cyclopropane. All right, let's continue on. Now, let's skip this one. Let's go. If only one substituent is present, then no number is needed. When you have one substituent on a ring, you don't need a number. So if I have the following, how do we name this? Everybody see that on my whiteboard, okay? Thank you. Well, first of all, how many carbons in the ring? 1, 2, 3, 4, 5. That's pentane, but it's a ring, so it's cyclopentane. Am I done? No. As soon as I say cyclopentane, that's spoken for. Oh, look, it's soon to be your really good friend, the methyl group. Therefore, as the alkyl or substituent, alkyl group or substituent, and this is methyl cyclopentane. When there's only one group on a ring, you use no number. And this is why. Does everybody see the new molecule I just wrote? What would be the Iupac name for that? Well, the ring has 5 carbons. Which would be pentane, but it's a ring. As soon as I say cyclopentane, that's all spoken for. Oh, look, it's your good friend now, the methyl group. So this would be methyl. Hold on. Let me start back here so you can see the little L better. Methyl cyclopentane. And if we look at structures A and B and say, are those the same? How come they have the same names? They look different. And I would say the following. Is this my right hand or is this my right hand? Is this it or is this something different? All I've done is rotated X degrees. And that's what I've done with the ring. Rings, like my hands, move all the time. They're not glued to a piece of paper. All right, first question you need to answer is, how many carbons are in that ring? Your turn. When you think you know, give me a thumbs up. Okay, I think everybody's done. The answer is 6 carbons. We call 6 carbons hexane. What would be the root name for that ring? I'll give you 6 seconds. And the answer is cyclohexane. Now, as soon as I say that, this is spoken for. And notice we have a alkyl group I haven't talked about because in alkanes, it's hard to draw a long structure other than 10 carbons with that. And notice I have 3 CH3 groups attached to the center carbon attached to the ring. Does anybody see something similar on the chart in front of you now? And the answer is yes. It's a tert-butyl group, one of Dr. White's favorite groups. Now you know I'm an organic chemist when I tell you I have favorite alkyl groups, and I do. So what do we have up here? A tert-butyl group. So this would be tert-butyl. Cyclohexane. Don't forget to put the cyclo. Common mistake on test 1, student would put down tert-butyl hexane, and I'll mark it wrong. If you get the root name wrong, I will never give you any points, even if you have the alkyl groups correct. All right, let me have you try one. What would be the Iupac name for the following molecule? 3 points each. 4 carbons, butane. I see one person's done. When you're done, take your time. I try and give everybody time to finish. And if I'm not giving you enough time, email me or privately send a chat message. You're not giving me enough time, Dr. White. And I'll say, oh, I'm sorry. And I'll make sure I give you everybody more time. All right, looks like everybody's done. Let's do this. What do I have? A ring. There are 4 carbons. 1, 2, 3, 4. That's butane. But it's a ring, so it's cyclobutane. And am I done? No, as soon as I say cyclobutane, I've talked about that. Oh, I've got something left over. It's your good friend, the methyl group. So that would be methyl cyclobutane. Now, here's where things get a little interesting, but relax, you'll get it. When there are 2 or more alkyl groups or substituent groups are named, 2 or more alkyl substituent groups are named and numbered the same as alkanes, except the alkyl group with the highest alphabetical priority is located at carbon 1 or given carbon 1. Now, I will not hold you to this rule. So that will mean there'll be different combinations, but I will hold myself to the rule. What does this mean? Let's look at the following molecule. First of all, what do you see? Does everybody see the ring? I hope you do. And how many carbons in the ring? 1, 2, 3, 4, 5, 6. That's hexane. It's a ring, so it's cyclohexane. And as soon as I say that, this is spoken for. Now, oh, look, it's a methyl group. And an ethyl group. Now, I'm going to follow the Iupac rule, which is closer to the front of the alphabet, E or M. And the answer is E. When you have more than one alkyl group on a ring, each one needs a number. So therefore, this is going to be carbon 1. And I go into direction clockwise or counterclockwise to give the other alkyl groups the lowest numbers. And therefore, we're going to go counterclockwise, and that's on 3. Notice if I went the other way, 1, 2, 3, 4, 5, which is a smaller number, 3 or 5. Hopefully, all pick 3. So this would be E comes first, so it'd be 2 up, 2. Come on, get it right, Dr. White. 1 ethyl, 3 methyl, cyclohexane. Let's go through how I got that. And then I'll tell you my gift to you, which I just mentioned. Ooh, 2 gifts today. This is a banner day for you people. Anyways, the ring, 6 carbons, cyclohexane. I have a methyl group, ethyl group on there. The group with the lowest or highest alphabetical priority near the front, ethyl, gets the number 1. The other group gets the lowest number, counting clockwise or counterclockwise, 3. So it's 1 ethyl, 3 methyl, cyclohexane. But you just said you're not going to hold us to that rule. and you're not going to hold us to the alphabetical rule. So this, what I've written, is the correct Iupac way of doing it. However, on the test, if you had put down 3-methyl-1-ethyl cyclohexane, I would have given you correct full points. If you had put down, instead of 1, made this 3 and made this 1, so it'd be 3-ethyl, 1-methyl. Please don't tell the Iupac, please, I'm letting you do this, but I will. That would be correct. And if you put 1-methyl, 3-ethyl, have those names switched, so there would be 4 possible answers. I would let you on a test, but if you follow fully the Iupac rules, this is the only name you could get. And that's how you do it. And why don't you try this one? What would be the Iupac name for the following? Let's see if you're up to it. Know something? And let's take a break. It's almost about time for a break. Instead of me rushing you to do this, which is not being nice, and I try and be nice, we'll come back and do this. Let's take a 5-minute break, come back at 2:50, and I'm gonna get up and stretch some more. That way I don't get any Charlie horses or cramps in my legs. It happens when you get mature muscles like mine. I'll see you in 5. Time to get going. Oh, let's do a different whistle. Time to get going. All right. Right before the break, and before I do that, let me just remind you, this is not the most exciting part of organic chemistry. But once we get through the initial, which we're doing now, nomenclature, trust me, next week it's going to get really exciting. You'll say, he's talking about that? And the answer is yes, I can in organic chemistry. So hang in there. Now, I just asked you, your turn, give the Iupac name for the following ring. And give me a thumbs up when you're done. Thank you. Just think about it. You're doing organic chemistry and it's not that painful. It might be even a little fun. All right. I see a number of thumbs coming up. Or for those who want to do the raised hand one. All right, let's do this. How do you do this? First of all, oh, I have a ring. And I don't know if I told you this, but Mother Nature and Dr. White love rings. I really do. And here we have 1, 2, 3, 4, 5, 6 carbons. That's hexane. But because it's a ring, it's cyclohexane. Don't forget the cyclo. Common mistake on test 1. People don't. Now, as soon as I say cyclohexane, that's spoken for. Now I have, an ethyl group and your good friend, a methyl group. So I'm going to follow the Iupac alphabet rule. Put the ethyl first and the methyl second. If you have them switched, that's okay, because I'm not holding you to that rule. All right, come on, why is my eraser not? All right, I've got to close down. This happens every once in a while. So I've got so many things opened up. All right. It doesn't like me. The joys of using Zoom on there. So we have cyclohexane. We have an ethyl group and a methyl group. And the group with the highest alphabetical priority, closest to the front of the alphabet, would be 1. If I go clockwise, it won't give me. If I go counterclockwise, the methyl is on 2. Therefore, it'd be 1 ethyl, 2 methyl. Let me just show you. If you want the other way, 1, 2, 3, 4, 5, 6, which is a smaller number, 2 or 6. Hopefully, I'll pick 2. Now, if you'd put 2 ethyl, 1 methyl cyclohexane, I give you full credit. If you put 2 methyl, 1 ethyl, the methyl first, I give you. If you have the number name swap, I'd give it to you. All right. Let's do one more. Let's see if you're really up to the challenge. Five carbons, pentane. Why don't you try this one? What would be the Iupac name for the following? And see, I've got you all trained, or better yet, more polite way is you're helping me out, giving me a thumbs up when you're done. If you're not done, take your time. All right, time's up. What do we have? Oh, we've got a ring. How many carbons? 5. 1, 2, 3, 4, 5. 5 carbons is pentane. I should have told you that, sorry. But it's a ring, so it's cyclopentane. And then, oh, we've got 1, no, 2. It's your old friend, the methyl group. So how do we say 2-dimethyl? Now, I might have given you a little too hard of an example here. So if you had trouble with this, don't worry. That's why we do practice problems. Now, as soon as I see di, I know I need 2 numbers. And since they're both the same group, one will have to be 1, and the other you go in the direction to give the lowest number. And this way is, I call this one 1, this is on carbon 2. 1, 2-dimethyl cyclopentane. Now, if I counted the other way, 1, 2, 3, 4, 5, which is smaller, 2 or 5, hopefully I'll choose 2. All right, that's how you do cycloalkanes. However, there are 2 main skills, meaning questions I can ask on a test, and that is One, here's the structure, give the Iupac name. The other is, here's the name, draw the structure. So let's take a look at that. And if I were asked you, draw the structure for cyclopentane. What do? You start from the right, move this way. Well, pentane, I know, is 5 carbons. Oh, time for a public service announcement from Dr. White. Make sure you learn this table as soon as possible, ASAP. And 5 carbons pentane. But we have cyclo prefix, which means we have a ring with 5 carbons, and it looks like this. Your turn. Draw the structure for B, cyclohexane. If your rings don't look as good as mine, don't feel bad. When I started out, mine were pretty awful. And once in a while, I even have a bad ring drawing day. It's like, have you ever heard of people having bad hair days? Well, I can have a bad ring drawing day. Thank you. I see one person done. Oh, more are falling in line. All right, I think everybody's done. How do we decode this to know what to draw? You start from the right, move left, hexane. And hopefully you will all get the hint. Learn this table, hexane, 6 carbons, hexane, 6 carbons. So I have 6 carbons, but oh, look, prefix cyclo. That means I have a ring with 6 carbons. And that's how you do it. Now let's go to alkyl groups on there. And I'll do this one. How do you draw N-Propyl Cyclobutane? Well, you start from the right, move left. Butane, 4 carbons, cyclo. That's a ring with 4 carbons. You call it a square, I call it a ring. Next, we have N-Propyl. I haven't used that one. So let's go to the table. Also, you should start memorizing. Guess what? I didn't open it up when I closed everything down. Hang on 1 second. All right. N-Propyl, notice this is a key alkyl group. You should learn this table as soon as possible. write down like this one, CH3, CH2, CH2 with a little line, that's N-Propyl. So I have 3 carbons, the N carbon in this case is connected to the ring. Now, which carbon can you put it on? When there's one group, you can put it on any one. So I'll put it on this one. Now, notice on the table, it had this. And sometimes this causes confusion for students. So let me try and clarify it. Notice here, I have 3 carbons. The N carbon is attached to either a ring or chain. And up here I have 1, 2, 3 carbons, and the N carbon is attached in this case to the ring. And that's an N-Propyl group. And the others are the same way. And now let me have you share in the fun. And why don't you draw the structure for ethyl cyclopentane? Now, let me help you out. First, I'll do this. Pentane, how many carbons? Oh, look, it's right there, 5. And ethyl group, how many carbons? I'll let you figure that out from the table. And now draw ethyl cyclopentane. All right, let's go back and do this. How do you decode this? You start from here and you move from the right to the left. Pentane, 5 carbons. Cyclo, it's a ring and it's a pentagon, or as I like to think of it, the little green house from Monopoly. How many of you have played Monopoly? Uh-oh, some of you have. Did your brother or sister steal from the bank when you went to the bathroom? Oh, we played cutthroats. This one we were about 7 or 8. All right, now we have an ethyl group, 2 carbons, and you can put it on any one. Now, there's free rotation around a carbon-carbon single bond, so you can write it like that. This is the same thing. N carbon of 2, and you could have also written it like this. And these are all the same structure, ethyl cyclopentane. Now, let's have a little more fun. And I'm going to see if you're ready for the big time. Let's see if you're up to the challenge. Draw the structure for 1-ethyl 4-methyl cyclohexane. Hexane is 6. And hopefully all of you know what an ethyl group is by now. Look above. And your good friend, the methyl group. I see some of you are finished. Doesn't that feel good? You're starting to understand this stuff. If you're not, don't forget tonight, I have my office hour from actually hour and 15 minutes from 5 to 6:15. If you need any help, feel free to stop by. It's a different Zoom login. It's in the syllabus. It's also on the first page of Chem 170 and D2L. All right. You know, some people are finishing. If you're done, don't forget, give me a thumbs up. All right, I think everybody's done. Let's do it. Start from the right to decode what's the structure, figure it out. I see hexane, 6 carbons, but I see cyclohexane. That means I have a ring. And I have on there a methyl group and an ethyl group. I'll call this carbon 1. You call any of those carbon 1, and that has an ethyl group on it. If that's carbon 1, whether I go clockwise or counterclockwise, this is carbon 4, and that has a methyl group on it. And that would be one way of drawing it. Another way, and all I'm doing is rotating it, would be this. And there are other ways, and I know the same. And that's how you do it. Anybody have any questions about nomenclature of the alkanes or cycloalkanes? Remember, there are 2 skills, 2 questions I can ask on the test, and that would be, here's the structure, give the Iupac name, or here's the name, draw the structure. Well, in that case, let's move on to something a little more exciting, even though this is very important. So we've done the alkyl group, cycloalkane nomenclature. All right. One of the things I've mentioned the other day, I think, every once in a while, I'll go click, the switch is off. And sometimes on entrance exams, some people have told me, I haven't taken them, where they'll ask stupid questions, but I'll go over this. Boiling points, temperature which something boils. This will never be on a test of mine or the final, but boiling points of alkanes rise as the chain length increases. The more carbons you have, the higher the boiling point, and it falls as the chain for isomers. Say if you have 8 carbons, 1 straight chain, 1 is branched with not full straight chain across, but still has 8 carbons. As chains become more branched, the boiling point is lower than the straight chain non-branch. I won't ask that on test, but sometimes I've been told people have that. Now, switches off, conformations are stereoisomers in which the atoms are connected away, but they arrange differently, and I'm going to skip this. All right, let's talk about reactions. In this course, one of the most important things I'll be teaching you are what we call general reactions. Right now, that's a door. And whether it's that door in your house, or the door at the chemistry building at ECC, you know, hopefully if you know what doors are, what to do. Well, in organic chemistry, functional groups or types of molecules react the same way. Why are you learning general reactions? Because those are the building blocks organic chemists use, synthetic organic chemists, to make molecules in our daily life. Like the molecules in this bottle that make up this plastic bottle, not the water that's inorganic, or the laundry detergent I use to clean my top and you use to clean your clothing, or many other things that use organic chemistry. And the first reaction I'm going to teach you, the general one, is the following: combustion. And actually, I should have also written and we really don't need this there. If you have an alkane or cycloalkane, react with oxygen, you actually need a little spark or heat source. This is called combustion. This is what's going on in your gas engine in your car. It reacts with oxygen to make carbon dioxide, CO2, water. Now, heat is not a chemical, but that's the important part. And this is a very important reaction alkanes undergo. Now, I should mention, just synthetic organic chemistry, combustion is boring. However, right now it's one of the most important reactions in our world, because that's how it makes your car go. And that's how this winter you'll have heat in your house, apartment, or condo. Your furnace burns methane and alkane. And for most of us, unless you have electricity, electrical cooking, electric range or oven, that's how you cook your food. Also, if you have a barbecue, alkanes burn to form heat to cook your food. So let's look at the following. And the question is 3 points each, give the product or products. And that's what I mean by this. You have more than one product, you have to give them for the following reaction. And sometimes I'll just say 4. Well, what do I do? Well, you look at the starting materials. Quick time out for a quick refresher. Here's a chemical reaction. A plus B makes C. A and B, if you're in academics, are called the reactants. You spend as many decades as I have in the chemical industry, we call those the starting materials. And if you heard me just say that, and they're always at the base of the arrow this side. And then at the head of the arrow, we call that the product or products. You have more than one, and that's the same for academics. So A and B are your starting materials or reactants, and I'll always use starting materials. It's too ingrained in my brain. Ooh, that rhymes. And at the head of the arrow are the products. So let's go back and look at the question. If you react this, which is propane, with oxygen, what do you get? Well, how do you know what to get it? You have memorized, yes, memorized the following general reaction. If I take an alkane or cycloalkane, react it with oxygen, the products I get, chemical products, are CO2, carbon dioxide, and water. You don't have to put down heat because that's not a chemical product, even though this is probably the most important thing of that reaction. So what do? This is an alkane. Now you don't have to write this down, but I'm going to write down or cycloalkane plus O2 is CO2 plus water. So the answer here is CO2 and water. And that's how you do it. And now it's time for a big gift from Dr. White. Organic chemists are lazy. Yes, we are. And unless you're doing the calculations to find out how much weights of each starting material you have to use to determine how much weight or of a product you will make or you need to make by reacting a certain amount of two chemicals together, organic chemists don't balance equations. If you're not doing that, you don't have to balance the equation. In this class, you'll never be doing that. So in my class, you'll never have to balance a chemical equation. Because organic chemists, when we're doing what I'm teaching you in this semester is, what am I going to make? Not how much of it, just what am I going to make? So if we look at the following, I'm done. What's the answer? CO2 and water. Now, this is the beauty of general reactions. Think of them as roadmaps. If you were trying to get from, say we're at ECC, from Elgin to Spokane, Washington. That's one of the few cities in the United States I haven't been to. I've been in Washington State, but not Spokane. But anyways, what if you were trying to get there from Elgin? Well, if you didn't have a map or GPS, what's the odds of you're going to doing that quickly or at all? Zippo, zero. But with a map or a GPS, that essentially a map, you will be able to get your way to Spokane. It's going to take you a while, but you'll get there. Well, general reactions are the same way. If you don't know them, you're not going to be able to figure out what are the product or products where you're trying to get to. Plus, you're going to lose a lot of points on the test. So it's something you have to remember to memorize. And the same thing, write it down 3 times and say it. So here's the general reaction. This is the first one. A couple of years ago, a student counted how many I had. I can't remember. I think it was about 52 we do in this class. I personally know about 400 general reactions. I cover all of them? No, I only have one semester, but I'm covering the important ones that I feel important. And students have found that useful. So let's do another one. And I'll do this one, then I'm going to let you have some fun. And the question is, give the organic product or products for the following. Oh, butane, that's an alkane. But it could have been a cycloalkane. Reacted with oxygen, general reaction tells us I get CO2, carbon dioxide plus water. Well, this is an alkane, this is oxygen. I'm going to get CO2 plus water. And now I'm going to share the fun. And your turn. What would be the product or products for the following? Remember, what's a molecule with only carbon-carbon single bonds and hydrogens, and is, in this case, acyclic. Begins with the letter A. And when you're done, give me a thumbs up. All right, looks like everybody's done. So let's take a look at this. What is this? Well, it's only got carbon and hydrogens and carbon-carbon single bond. It's an alkane. And now this could be an alkane or a cycloalkane. I'm reacting with oxygen. My general reaction, which you are going to learn, hint, gives me CO2 plus water. And now I know alkane, this is it, oxygen. I'm going to get CO2 plus water, and I'm done. That wasn't that hard. Now, here's a really deep secret. Chemistry instructors trick on a test. If students don't know how to identify types of molecules, chemistry instructor puts up big, scary molecule. But if you know what it is, it's not big and scary. But if you don't know what it is, it's a big and scary molecule. And let me show you how that works. And the question would be, what's the product or products for following reaction? And now you look at this and you go, eek, it's a big scary molecule. No, it's only carbon-carbon single bonds, carbon hydrogens. It's an alkane. Now, it could have been a cycloalkane, which it's not, but it could have been. Plus oxygen, you've learned this general reaction hint. Learn this or memorize this, and you get CO2 plus water. Therefore, this is an alkane, oxygen, I'm going to get CO2 plus water. And that's it. But if you don't know the general reaction, guess what? You're lost, like someone without a map trying to go to Spokane, Washington. And let me have you try one. Your turn. What would be the product or product for the following reaction? 3 points each. And I'd like to thank everybody for getting the hang of doing the thumbs up. Everybody's done. So let's take a look at the, oh, a big scary molecule. Oh no, no. What is it? Carbon, hydrogen, carbon, carbon, single bonds. It's an alkane. And it could have been, I haven't done one today, but there's some in the problem set. Cycloalkane, a ring. Reacted with oxygen, gets CO2 plus water. Therefore, this is an alkane. It is. I'm going to get reacting with oxygen, CO2 plus water. You'll get heat, but I'm looking at the chemicals. And that's how you do it. Now, if you notice underneath each of these examples, I have written the general reaction right here. Now, I should mention some of the very best students I've ever had. Whenever I have that kind of question, give the product or products, they always write the general reaction underneath to help them. Some of the best students I've ever had in Chem 170 never write the general reactions underneath, but they have it up here. Both of them do, but they just don't write it underneath. Now, I will always write it on any example I show in this class. That's to help you learn it. I've got them all stored. I think it's right back here, all the ones I know. But anyways, I'm an organic chemist, so I should have more, and I should have them stored. You can do either way. All right, let's move on. I don't have a slide for it, so let's talk about something important. One of the important things I like to stress in this class is, where do you find this stuff in your everyday life? Because that's what makes it exciting. So let's find out, where do you find alkanes in your everyday life? Well, one is methane, and we call that natural gas. And that's used for your stove, your oven, your furnace in Northern Illinois. Most of the United States, I think, uses natural gas as opposed to, when I was young, we used to have oil delivered to our house. Then by the time I was about 10 or 11, I and all our neighbors switched over to natural gas, became affordable. What's another one? Propane. And what do we use that for? Our barbecue. Now, when you have more longer hydrocarbons mixtures, we have gasoline. Now, if you have longer chain lengths of carbons, you'll get a product that's semi-solid, which I'll use a trade name, Vaseline. If you had a little less carbons, but almost as many as Vaseline, another product that you can buy that's essentially alkanes is baby oil. And by the way, if you don't know, baby oil and Vaseline are flammable, not as bad as gasoline. But I remember I had a nurse who was going back to get her master's degree in my class, Chem 170, and she, when I talked about baby oil, said she works in neonatal care, and we always warn new parents, if you're going to use baby oil, make sure you don't have any candles nearby or you're smoking, because it's very flammable. Now, if you get the much longer chains of carbons or molecular weight, a lot of carbons, we have larger molecules, and one of them is called paraffin. Thin wax. It's a white, waxy solid, and 50% of a candle is made up of paraffin wax. The next time you look at a candle, half that weight of the candle is a very large alkane. So what does this all mean? On a test, I could get asked, give an example of an alkane you use in your daily life. And you could put down methane, natural gas, propane, barbecue, gasoline, Vaseline, baby oil, or paraffin wax. Those are all examples. Now, when you leave my class, you should still think about organic chemistry. It won't hurt. Next time you're out driving around, when you happen to pass by a gas station, remember a good part of the way to the gasoline is the alkanes, and you now know what an alkane is. Or if you happen to see some Vaseline or baby oil being sold, or if you have it in your house, that's got alkanes. Now, a classic, one of my, I'm looking at how much time I have left, because I don't like to go over, it's not polite to you, the students, is for a while I was into survivalist hobby. You know, what do you need to survive on your own for 3 days or more? Maybe usually 3 days, they say. And hopefully you all have, with strange things going on in our world today, a bug out bag where it'll help you live for 3 days. And one of the most important things is to be able to make fire. And a survivalist trick that I know about, and I knew sort of before, but I've read about it more, a lot of people. In your bug out bag, you have a Ziploc baggie with cotton that you rub in Vaseline. You could do baby oil, but it might leak out of the bag. So Vaseline is better. And now, because Vaseline is an alkane, which you saw is combustible, burns with oxygen, that is a way to help you make fire easier than just having cotton alone or other things that will burn. And that's a survivalist thing. All right. We finished chapter 1, or actually chapter 2, alkanes and cycloalkanes. Next Wednesday, I will go through chapter 2, alkanes problem set. I highly recommend you do them on your own before I go through some of them. Am I going to go through the whole thing? No, but I'll pick some. And if you have any questions, want me to go through it during when we do it in the class, ask, and I will. I always will. And don't forget, when you drive by a gas station, think about alkanes. It won't hurt, because organic chemistry is all around us. I stole that from SpongeBob. I don't know if you saw the one where he does imagination with Squidward and Patrick. Yeah, I like cartoons. I haven't outgrown that, thank goodness. But anyways, don't forget, tonight, 5 to 6:15, office hour if you need help. Good news, you don't have to see me for the rest of the week. No, that's not nice, bad Dr. White. But anyways, I'll see you on Monday. After next week, on Wednesdays, we'll have lab. I'll lecture for 50 minutes. We'll do a lab. I'll show you how we'll do that, not next week, but the following week. Remember, I'm trying to make up time I'm losing on Labor Day. And usually after, not next week, but the following weeks, we'll be done by the latest 2 on Wednesday, which in real life we'd get out early too if we were face to face. And with that, I'll say, don't forget, wear a mask when you're out there. It's getting bad. Don't forget, if you don't have the vaccine, get it, please. I got mine in April. All my life, certain shots I reacted quite badly to. When I got a tetanus shot a number of years ago, my left arm was shot, where I got the shot, was paralyzed for about 3 days. I just couldn't use it. That was not fun. But when I got both of my shots, I got the Pfizer, no problem other than a little soreness for a couple hours. It was essentially nothing. Get it. And with that, I'm going to say, gehen gesund, be healthy, go in health. Goodbye. I'll see you on Monday at 1. Don't forget, if you want, look at my YouTube channel. This lecture today should be up there late today or early tomorrow. With that, I'll say, gehen gesund. Bye now.